Hello everyone. In today's lecture, we will learn about the remainder of powers. Right? In today's lecture, we are going to solve a number of questions related to remainder of powers. And yeah, UPSC CSAT has asked questions related to remainders of powers. Right? That's why you should be good at solving these questions. In yesterday's lecture, we have learned that the remainder of the product of two numbers a and b when divided by n is equivalent to the product of their individual remainders when divided by n. What does it mean? It means that suppose if there are 2, 3, 4, 5, 6 numbers or even more than 6, 7, 10, right, numbers, and if you have to find the remainder when those numbers are multiplied with each other and those numbers are divided by some number, then what do? You simply divide 18 by 13, you write the remainder. You divide 30 by 13, you write the remainder. You divide 55 by 13 and you write the remainder. Then you multiply all of those numbers, right? And then you get some number, and if that number is less than 13, you answer that, yeah, this is the remainder. Okay, we will solve a number of questions, then you will be able to relate with this concept more. See, if you divide 18 by 13, you get 5. If you divide 30 by 13, you get 4, right? If you divide 55 by 13, you get 3. 13 into 1 is 13, so 5. 13 into 2 is 26, so 4. 13 into 4 is 52, so 3. 5 into 4 into 3 is 60, and again you will have to divide 60 by 13 and you get answer that 8 is the remainder, right? So we use this concept to solve the questions of remainders of power. So what is the question? The question is, if 3 to the power 2019 is divided by 10, what is the remainder? How will you solve this question? Simple. You will do one thing, that 3, if you divide 3 to the power 1 by 10, tell me what will be the answer. Basically you are dividing 3 by 10, so you will get remainder that is equal to 3. If you divide 3 to the power 2 by 10, so 3 to the power 2 is what? 3 to the power 2 is 9. So basically you are dividing 9 by 10, and if you divide 9 by 10, what will be the remainder? The remainder will be equal to 9, right? Then you divide 3 to the power 3 by 10. What is 3 to the power 3? 3 to the power 3 is 27, right? So 27 by 10, what will be the remainder? The remainder will be equal to 7. Then you divide 3 to the power 4 by 10. So tell me, what is 3 to the power 4? 3 to the power 4 is 81, right? So basically 81 by 10. So what will be the remainder? The remainder will be equal to 1. So now notice this thing, that if you divide 3 to the power 1 by 10, remainder is 3. Then if you divide 3 to the power 2 by 10, the remainder is 9. If you divide 3 to the power 3 by 10, the remainder is 7. If you divide 3 to the power 4 by 10, the remainder is 1. Now if you divide 3 to the power 5 by 10, so basically you get what? 243. And if you divide 343 by 10, you get remainder as 3. Now you can notice one thing. You should be able to notice one thing. Now remainders have started to repeat itself. 3971. So 3971, right? What does it mean? It means that if you divide 3 to the power 1 by 10, remainder will be equal to 3. If you divide 3 to the power 2 by 10, remainder will be equal to 9. If you divide 3 to the power 3, remainder will be equal to 7. If you divide 3 to the power 4 by 10, remainder will be equal to 1. Similarly, if you divide 3 to the power 5 by 10, remainder will be equal to 3. If you divide 3 to the power 10 by 6, remainder will be equal to 9. If you divide 3 to the power 7 by 10, so remainder will be equal to 7. If you divide 3 to the power 8 by 10, remainder will be equal to 1. So basically, after getting remainder 1, all the remainders start repeating itself, right? So we have found the pattern, that what is the pattern of remainders? 3971, 3971. if you write it further, you will again get remainders 3971. Now we will have to look at the questions. The question asks that if you divide 3 to the power 2019, if you divide 3 to the power 2019 by 10, what will be the remainder? Okay, the remainder will be 1 of 3971. And if you look at the options, the options are 3971. So basically 3 to the power 2019 will fall in maybe in one of these 4 numbers, right? So basically you will have to do one thing. You will have to divide 2019 by 4. Why we are dividing 2019 by 4? You can notice that after 4th power, the remainders have started to repeat itself. After 4th power, see 3971 means after 4th power, the remainders have started to repeat itself. So basically you have to divide 2019 by 4, and if you divide 2019 by 4, so 4 into 5 is 20, then 0, then 19. So 4 into 4 is 16. So what is the remainder? The remainder you are here getting is 3. What does it mean? It means simply that this follows in the pattern. See, what are you getting as remainder? You are getting remainder as 3, right? You are getting remainder as 3. So basically this is 3 to the power 3 by 10 will give you the same remainder that 3 to the power 2019 divided by 10. So now let us look at 3 to the power 3. If 3 to the power 3, so what is the remainder? The remainder is 7. Look at here carefully. If you got remainder 3, what does it mean? That 3 to the power 2019 by 10 will give you the same remainder 3 to the power this 3 by 10. And so 3 to the power 3 by 10 will give you remainder that is equal to 7. I am explaining in a different way. See, 3 to the power 2019 by 10. So basically you can write it as 3 to the power 2016 into 3 to the power 3 divided by 10. See, why we have written that in the form of 3 to the power 2016 into 3 to the power 3. See, you have got remainder 3 if you have divided 2019 by 4. What does it mean? It means that if you subtract 3 from this number, 4 will completely divide it, right? And if you subtract 3 from this number, it will be equal to 2016. So 3 to the power, if the question is 3 to the power 2016 by 3, so basically 3 to the power 2016 by 10, in that case remainder will be equal to 1, right? But now this will give the remainder of 1, but this will give the remainder of 7. So 1 into 7, that is 7, right? You can think this question in a different way. Let's see, when the power is 1, so you can write that when the power is 4k plus 1. Why we have written here 4? Because the remainders are repeating after 4th power. So if the power is 4k plus 1, you get remainder 3. If the power is 4k plus 2, you get remainder as 9. If the power is 4k plus 3, you get remainder as 7. If the power is 4k plus 4, you get remainder as 1, right? And you can notice this thing, that you can write 2019 as 4 into 504 plus 3. So you have basically written 2019 as 4k plus 3. See, if you put the value of k as 0, then if the power is 1, remainder is 3. If you put the value of k as 0, so the power is 2, remainder is 9. If you put the value of k, that is 0, so if the power is 3, the remainder is 7. If you put the value of k as 0, so if the power is 4, remainder is 1. Similarly, if you put the value of k as 1, so 4 into 1 plus 1 is 5. So if the power is 5, remainder is 3. If you put the value of k as 1, so 4 into 1 plus 2 means power is 6. So when the power is 6, remainder is 9. If you put the value of k as 1, so 4 into 1 plus 3, that is equal to 7. So if the power is 7, remainder is 7. If you put the value of k as 1, so 4 into 1 plus 4 is 8. So if the power is 8, remainder is 1. So basically this is the pattern, and see, you can write 2019 in this pattern, 4 into k plus 3, 4 into k plus 3. See, you can notice 4 into k plus 3 even by looking at this division. So 4k plus 3 means basically 4k plus 3. So what is the remainder? Remainder is 7. See, this question is not truly difficult. You should count these questions as easier questions. If you practice few more questions on these concepts, you will be able to answer these questions quickly and correctly, right? We need to solve few questions to be comfortable with this kind of questions, right? So whatever way you are comfortable with, see, if you are comfortable in this way, see, why we have written 4 into k? Simple way is that because the remainders are repeating after fourth power. That's why 4k plus 1, 4k plus 2, 4k plus 3 and 4k plus 4. Why till 4? Simple reason is that 1, 2, 3, 4, right? And don't worry, we will solve few more questions, and then you will be able to apply this concept to solve those questions. So the correct answer is 7. Now let us look at this question. See, this question has been asked in 2023, and if you look at this question has been asked in CSAT 2021. So CSAT does repeat the pattern of its questions. That's why we suggest all of the aspirants to solve the previous year questions of CSAT, right? And we don't teach that you should mud up all of those things. You should try to understand the basics, such that even if they tweak question up to some extent, you should be able to answer those questions, right? So now look at this question. The question is, what is the remainder if you divide 2 to the power 192 is divided by 6? Again, we will follow the same pattern. If you divide 2 to the power 1 by 6, this is equal to 2 by 6. If you divide 2 by 6, then obviously the remainder will be equal to 2. We similarly followed this pattern while dealing with earlier question, right? So again, you will write 2 to the power 2 by 6. This is equal to 4 by 6. And if you divide 4 by 6, you will get remainder as 4. Are you able to notice? If you divide 4 by 6, obviously you will get remainder that is equal to 4, right? Then again, you will write 2 to the power 3 by 6. See, why we are trying to find pattern? Because we have to divide 2 to the power 192 by 6. That's why we have started to divide 2 to the power 1 by 6, 2 to the power 2 by 6, 2 to the power 3 by 6, 2 to the power 4 by 6, 2 to the power 5 by 6. And again, we will try to find the pattern of remainders, that do the remainders repeat itself, and if the remainders repeat itself, what is the pattern, right? So basically 2 to the power 3 by 6 is equal to 8 by 6. So if you divide 8 by 6, you will get remainder as 2. Now are you able to notice this thing? 2, 4 means again 2. See, even if you solve it further, you will find 2 to the power 4 by 6. 2 to the power 4 by 6 is 16 by 6. So obviously the remainder is 4. So are you able to notice these things? The remainders are repeating itself in the form of 2 and 4, right? So basically, if I say, if you divide 2 to the power 1 by 6, remainder is 2. 2 to the power 2 by 6, remainder is 4. If you divide 2 to the power 3 by 6, remainder is equal to 2. If you divide 2 to the power 4 by 6, remainder is equal to 4. This will pattern the same pattern. This will follow the same pattern. Even if you divide further, you will find that these numbers are following the same pattern. If you write 2 to the power, if you divide 2 to the power 5 by 6, you will find that the remainder will be equal to 2. See, 2 to the power 5 is 32. And if you divide 32 by 6, remainder will be equal to 2. If you divide 2 to the power 6 by 6, again the remainder is 4. So basically, see, once you get comfortable with this kind of questions or concept, you don't need to solve it till this point. See, at this point, you found that now remainders have started to repeat itself. So tell me how the remainders have started to repeat itself. In this question, you can notice one thing. If the power is odd number, if the power is 135, if the power is odd number, if the power is odd number, in that case remainder is 2. If the power is even number, if the power is even number, in that case remainder is 4. So basically you can quickly answer that the correct answer is 4. that the correct answer is 4 of this question. But suppose if you are not able to notice this kind of pattern, how will you find? Simple. See, you will do one thing. See, remainders have started to repeat itself after second power. So you can write simple 2k plus 1 and 2k plus 2. In that way that we have written earlier, 4k plus 1, 4k plus 2, 4k plus 3, 4k plus 4. Why? Because the remainders started to repeat itself after the fourth power. But in this question, the remainders have started to repeat itself after second power. So 2k plus 1 divided by, if the power is 2k plus 1, the remainder is 2. If the power is 2k plus 2, remainder is 4. So let us look at 192. So you can write 192 as 2 into simple 95 plus 2. See, means this pattern. So remainder will be equal to 4. But I will suggest you that in this kind of question, you should be able to notice this thing, that if the powers are odd numbers, remainders are 2, 2 and 2. If the powers are even numbers, 2, 4, 6, remainders are 4, right? Or even if you are not able to write this kind of pattern, you can notice one thing. If the power is multiple of 2, if the power is multiple of 2, see, 2 is the multiple of 2, 4 is the multiple of 2, 6 is the multiple of 2, you are getting remainder as 4. 1, 3, 5 are not the multiples of 2. 1, 3, 5 are not the multiples of 2. So if the powers are not the multiples of 2, in that case you get the remainder that is equal to 2. And if you look at 192, if you look at 192 power, 192 is a multiple of 2. How do you check the multiple of 2? If 192 is perfectly divisible by 2, means it is a multiple of 2. Or even if you can look at 192, if you look at the units digit contains 2. In 192 at unit place 2 is there, means that number is obviously divisible by 2, right? If that number is obviously divisible by 2, means that number is a multiple of 2, right? So again you can notice that CSAT has asked an easier question related to the concept of remainder of powers, right? We will again solve few more questions such that you should be comfortable with this kind of question. Who knows, CSAT can ask this kind of questions in CSAT 2025, right? Now look at this question. What will be the remainder when 17 to the power 5 is divided by 5? Okay, you have to answer that. If you divide 17 to the power 5 by 5, what will be the remainder? Okay, I will suggest you, see, in earlier questions, if you can't divide, see, in this question you can't divide 3 by 10, right? You can't divide 3 by 10. If you look at this question, you can't divide 2 by, you can't divide, okay, where is that question? In this question you can't divide 2 by 6, means even if you divide 2 by 6, you can't divide, right? You will get the remainder as 2. But now look at this question. If you look at this question, the question says that you have to answer what will be the remainder when 17 to the power 5 is divided by 15. So let us divide 17 by 15. If you divide 17 by 15, it is basically, you will get remainder that is 2. So you can write this question in this way, 2 to the power 5 by 15. You can write this question in this way, that 2 to the power 5 by 15. Now you don't need to apply the concept of remainder of powers. What is 2 to the power 5? 2 to the power 5 is 32. 2 to the power 5 is 32. So can you divide 32 by 15? Yes, you will get remainder as 2. So the answer is 2. Sometimes you will think that the questions are difficult, complicated, but these questions are not complicated. You need to solve 10, 15, 20 questions related to this kind of concepts. Then you will be good at solving this kind of question. See, you have to answer that when 17 to the power 5 is divided by 15, okay, we can divide 17 by 15 and we can see that the remainder is 2. So basically this question is 2 to the power 5 by 15. So what is 2 to the power 5? 2 to the power 5 is 32. And if you divide 32 by 15, you will get remainder that is equal to 2. So the correct answer is 2. Even if you don't do that thing, Okay, let us solve this question by using the concept of remainder of power. Suppose you are not able to observe this kind of things. So how we will apply the concept of remainders of powers? Okay, you can start in this way. If you divide 17 to the power 1 by 15, this is basically this will give you the remainder of 2. Okay, if you divide 17 to the power 2 by 15, so basically this is 17 into 17 by 15. I have told you that if the numbers are in multiplication form, you divide each number separately. So if you divide each number separately, it will give you 2 into 2. See, if you divide 17 by 15, you will get 2 as a remainder. If you divide this 17 by 15, you will get 2 as a remainder. So 2 into 2 by 15. So 2 into 2 is basically what? 2 into 2 is 4 by 15. So the remainder is here 4. The remainder is here 4. Right? Now if you look at further, so you will divide 17 to the power 3 by 15. See, you can write it in this way, that 17 into 17 into 17 into 17 by 15. Again, you will get remainder 2. You will get remainder 2. You will get remainder 2. So 2 into 2 into 2 by 15. So basically 8 by 15. So again, you will get remainder that is equal to 8. That is equal to 8, right? Now, if you solve it further, 17 to the power 4 by 15. And if you solve it further, basically 17 into 17 by 15. So obviously 2 into 2 into 2, right? So 2 into 2 into 2 into 2 is equal to 15. So obviously this is equal to 16 by 15. So the remainder will be equal to 1. So the remainder will be equal to 1, right? So now you just have to solve one more time. 17 to the power 5 by 15. And I have told you earlier that once you reach the remainder 1, the remainders start to repeat itself. The remainders start to repeat itself. Means if you have found the remainder as equal to 1, means you will get the next remainder 2. You will get the next remainder 2. So you don't need to solve it further. But even if you want to solve, you can solve it. 17 into 17 into 17 into 17 into 17 by 15. So basically 2 into 2 into 2 into 2 into 2 by 15. So this is equal to 32 by 15. If you divide 32 by 15, you will get remainder as 2. You will get remainder as 2. So see, you can even apply the concept of remainder of powers in this question and you can get the correct answer. But if you are able to understand this approach, it will help you to solve questions quickly, right? So the correct answer of this question is 2. So the correct answer is 2. Let us solve one more question related to this concept. See, 18 to the power 99 divided by 13. You have to find the remainder. So can you divide 18 by 13? Yeah, you can divide and it will give you remainder that is equal to 5. So basically 18 to the power 99, you can write it in this way, that 5 to the power 99 by 13. 5 to the power 99 by 13. So now you have to answer what will be the remainder when 5 to the power 99 is divided by 13, right? So let us start solving this question. 5 to the power 1 by 13, it will give you remainder as 13. 5 to the power 2 as 13, it will give you remainder 5 into 5 by 13. So basically 25 by 13. So basically if you divide 25 by 13, you will get remainder that is equal to 12. If you solve it further, 5 into 5 to the power 3 by 13. So okay, you can write it in this way, 5 into 5 into 5 divided by 13. So 125 by 13. 5 to the power 3 is 125. And if you divide 125 by 13, you will get remainder that is equal to 8. That is equal to 8. But I will suggest you, why we are multiplying 5 into 5 into 5? I will suggest you that you don't need to do anything. See, the remainder, the earlier remainder is 12, right? And we have increased one power. Earlier the power was 5 to the power 2. Now the power is 5 to the power 3. So you only need to do one thing. So you can directly write 12 into 5. You can directly write 12 into 5 divided by 13. So 12 into 5 is 60 by 13. So remainder is equal to 8. So if you solve it further, 5 to the power 4 by 13. See, earlier the remainder is 8. See, earlier the remainder is 8, right? I have showed you two approaches. So you can directly write 8 into, you have increased one power, 8 into 5 by 13. So basically 40 by 13. If you divide 40 by 13, you will get remainder 1. I have told you that once you get the remainder 1, what does it mean? That now the remainders will start repeating itself. The remainders will start repeating itself. What does it mean? That remainders will follow this pattern. See, earlier the pattern was 13, earlier the remainders was 13, then 12, then 8, then 1. What does it mean? That if you solve further, if you divide 5 to the power 5 by 13, so basically 1 into 5 by 13, sorry, 1 into 5 by 13. Okay, 5 to the power, oh sorry, 5, right? This one is 5. So 5, 12, 8, 1. So see, you can notice that you have got remainder as 5. So 5, 12, 8, 1 and 5 means the remainders have started to repeat itself, right? Now look at 18 to the power 99. The remainders have started to repeat itself after fourth power. So you can write, when the power is 4k plus 1, the remainder is 5. When the power is 4k plus 2, then remainder is 12. When the power is 4k plus 3, the remainder is 8. When the power is 4k plus 4, remainder is equal to 1. So let us look at 99. You can write 99 as 4 into 24 plus 3. 4 into 24 plus 3, right? So basically this is the form of 4k plus 3. 4k plus 3. So what will be the remainder? See, 99 is the form of 4k plus 3. 4 into k plus 3. So the answer will be equal to 8. The answer will be equal to 8. Right? Now, let us solve this question. What will be the remainder when 2013 to the power 14 is divided by 7? So basically 2013 to the power 2014 divided by 7. Okay, you can divide 2013 by 7. So let us divide 2013 by 7. So 7 into 2 is 14, then 6 1, 7 into 8, 56, then 5 into, then 3, right? So 7 into 7 is 49. 7 into 7 is what? 49. So the remainder is 4. Means this question is equivalent to 4 to the power 2000. 4 is the remainder. So 4 to the power 2014 by 7. If you get this kind of questions, you should try to divide this number by this number, and whatever is the remainder, you can write it in that way. So 4 is the remainder. So now the question is that if you divide 4 to the power 2014 by 7, what will be the remainder? Okay, we will follow the same approach for now. If you divide 4 to the power 1 by 7, remainder will be equal to 4. 4 by 7 means remainder is equal to 4. 4 to the power 2 by 7. See, earlier the remainder is 4. So let us write 4, and you have increased one power more. So 4 into 4, or even you can think 4 to the power 2 is equal to 4 into 4, right? So 4 into 4 divided by 7 is what? Means 16 by 7. If you divide 16 by 7, you will get remainder that is equal to 2. Now you will write 4 to the power 3 by 7. See, you can think in one way that 4 into 4 into 4, that is 64, right? You can think that 4 into 4 into 4 by 7, that is 64, and if you divide 64 by 7, 7 into 9 is 63, means remainder is equal to 1. Once you get the remainder 1, after that remainders started to repeat itself. What does it mean? That remainders will follow this pattern, 4 2 1. So basically after third power, remainders have started to repeat itself. You can cross verify it. You can write 4 to the power 4 by 7. So basically 4 to the power 4 by 7 is what? 4 into 4 into 4 into 4 by 7. This is equal to what? This is equal to 256 by 7. If you divide 256 by 7, you will find that remainder is equal to 4. Or you can even think in this way, Let's see. Earlier the remainder is 1. So directly write 1. You have introduced 1 power of 4. So directly write 1 into 4 by 7. So the remainder is 4. You can notice 4, 2, 1 and then 4. Right? Means remainders have started to repeat itself. And the remainders are 4, 2 and 1. So you can write, see, remainders have started to repeat after third power. So you can write 3k plus 1. When the power is 3k plus 1, then the remainder is 4. When the power is 3k plus 2, remainder is 2. When the power is 3k plus 3, the remainder is 1. Now let us look at 2014. Let us look at 2014. We have to see. These are for the powers. When the power is 3k plus 1, when the power is 3k plus 2, when the power is 3k plus 3. So we have written different remainders when the power is of this form. See, why 3k? Simple reasons. Remainders have started to repeat itself after third power. So can we write 2014 as 3 into 6? See, you can directly divide it here. 2014 by 3. So 3 into 6 is 18. 2, 1, 3 into 7, so 0, then obviously 4, so 3 into 1. So basically you can write 2014 as 3 into 6, 7, 3 into 6, 7, 1 plus 1. So 3k plus 1, 3k plus 1, right? See, 2014 is in the form of 3k plus 1, 3 into 6, 7, 1 plus 1. So this is this power, 3k plus 1. So what is the remainder? The remainder is 4. Why the remainder is 4? The simple reason is 2014 is the form of 3 into k plus 1. When the power is 3k plus 1, in that case the remainder is 1. See, we have solved so many questions related to these concepts. I will suggest you that you should solve all of these questions again, right? And if you are still not able to solve it, you should look at the solution again. Trust me, if you put efforts to understand this kind of questions, you will be able to solve. You will have to put at least 30 minutes, 60 minutes to understand this kind of questions. After that, you will definitely be able to solve these questions, right? And you can expect one question from remainder of powers in CSAT 2025. Now we will solve few interesting questions that have been asked in CSAT. Let us look at this question. What is the remainder when 91 into 92 into 93 into 94 into 95 into 96 into 97 into 98 into 99 is divided by 1261. So basically they have asked you that you should divide this number by 1261. You should divide this number by 1261 and you have to answer the remainder. So tell me, will you be able to multiply all of these numbers? Do you have that kind of time to multiply all of these numbers? Then you will go to divide that multiplication, that number by 1261. That is not feasible. You will waste your time if you go to multiply all of these numbers. You will have to invest 20-25 minutes to solve one question. You don't have that kind of bandwidth in a competitive examination like CSAT, right? So what should be our approach? Our approach should be simple. See, let us try to prime factorize 1261. See, this number is not divisible by 2 because 02468 is not present at unit place. If you add all of the digits, 1 plus 2 is 3, 3 plus 6 is 9, plus 1 is 10. Means this number is also not divisible by 3. This number is also not divisible by 7. You can verify it if you divide 1261 by 7. See, why we are trying to divide it by 2, 3, 7, right? Because we are prime factorizing. Because we are trying to prime factorize 1261. What does it mean? That we will try to divide this number 1261 by all the prime numbers starting from 2. If you check that this number is divisible by 2, no. If this number is divisible by 3, no. If this number is divisible by 7, no. The next prime number is 11. The next prime number is 11. If you divide it by 11, this number is not divisible by 11. Now you should try to divide this number by 13. Yeah, this number is divisible by 13. 13 into 9 is 117. 13 into 9 is 117 and then 13 into 7. basically you can say that 1261 is equal to 13 into 97. Can you prime factorize 97 anymore? No, you can't prime factorize. The reason is simple, that 97 is already a prime factor. So how will you prime factorize 97 anymore? So basically 1261 is equal to 13 into 97. So basically you can write 1261 as 13 into 97. Let us write it in this way. See, we know that 1261 is 13 into 97. Let us write it here. 91 into 92 into 93 into 94, 95, 96 into 97 into 98 into 99. You have to divide this number by 1261, and we know that 1261 is 13 into 97. So basically let us look at the number 13 into 1 and 13 into 7, 13 into 1 and 13 into 7, then 97 into 1. See, this number is perfectly divisible by 13 into 97, means this number is perfectly divisible by 1261. If this number is perfectly divisible by 1261, means what will be the remainder? The remainder will be equal to 0. The remainder will be equal to 0. How did we find that 1261 is equal to 13 into 97? Simple way, that we tried to prime factorize 1261 and we tried to divide 1261 by all the prime numbers. We found that this number is not divisible by 2, this is not divisible by 3, this is not divisible by 7, this is not divisible by 11. Then we tried to divide it by 13, and when we divided 1261 by 13, we found that 13 can divide 1261, and we got 97. We can't prime factorize 97 anymore. The reason is simple, that 97 is already a prime number. So we wrote 1261 as 13 into 97. So basically we are dividing this number by 13 into 97, and we found that 13 into 1, 13 into 7, 97 into 1 and 97 into 1, right? So this number is perfectly divisible by 1261, means if this number is perfectly divisible by 1261, the remainder is obviously equal to 0. Now let us look at this question. See, if you observe, this question has been asked in CSAT 2022. If you look at this question is somehow on similar concepts, right? And this question has been asked in CSAT 2023. So you can again observe that CSAT does repeat the pattern of its questions. That's why it is relatively easier to crack CSAT if you really put efforts for few months, right? So let us look at this question. Now the question says, what is the remainder if you divide 85 into 87 into 89 into 91 into 95 into 96 by 100? Can you multiply all of these numbers? Yeah, you can, but will you be able to multiply all of these numbers in an examination scenario? No, you will waste your time. There are so many numbers. Even if you are good at multiplication, you will have to invest a lot of time to get the correct multiplication of those numbers. That's why I will suggest you that you shouldn't try to multiply these numbers. So what is the approach? Try to recall the approach of earlier question. In earlier question, we were dividing by 1261. We tried to prime factorize 1261. So similarly, we will try to prime factorize 100, right? So 2 into 50, 2 into 25, 5 into 5. So basically 100 is equal to 2 into 2 into 5 into 5. So basically we can replace 100, by 2 into 2 into 5 into 5. 2 into 2 into 5 into 5. Now notice one thing, 5 into 1 and 5 into 19, 5 into 1 and 5 into 70, right? Now notice 2 into 48, right? And 2 into 24. Are you able to notice this thing? This number is perfectly divisible by 100. we are able to divide this number completely by 100. See, 1 1 1 1 1 means this number is completely divisible by 100. If this number is completely divisible by 100, what does it mean? It means that remainder is equal to 0. Remainder is equal to what? The remainder is equal to 0, right? So the correct answer of this question is 0, right? So you should solve these questions again by yourself, right? Then only you will be able to observe that can you solve this. See, if you try to divide it by 100, our immediate response is that there are good chances that these numbers, this multiplication is not divisible by 100. But you don't need to worry, you just need to simplify. If you are able to find one option as 0, means there are at least some chances that this number is perfectly divisible. So why don't we try to divide it directly, right? See, even in this question, you are able to see 0 in one of the options, means there is at least some chances that this number is perfectly divisible by 1261, right? So now you can notice that CSAT doesn't ask very difficult questions related to the concept of remainders, right? Let us solve one more question related to remainder of powers. See, now the question is, what will be the remainder when 3 to the power 4, 5, 6, 7, 8 is divided by 16? Again, we will start solving in this way. 3 to the power 1 by 6. If you divide 3 by 16, you will get remainder as 3. If you divide 3 to the power 2 by 16, so basically you are dividing 9 by 16, so the remainder is 9. If you divide it further, so 3 to the power 3 by 16, so basically you are doing what? 3 into 3 into 3 by 16. So see, you have to answer 3 to the power 4, 5, 6, 7, 8 by 16. You can't divide 3 by 16 anymore, right? That's why now 27 by 16, what will be the remainder? Remainder will be equal to 11. Remainder will be equal to what? 11. If you solve it further, 3 to the power 4 by 16. So basically, again you can write 3 into 3 into 3 into 3 by 16. And 3 to the power 4 is obviously equal to 81. So 81 by 16. So now the remainder is 1. We have solved so many questions and I have told you that once you get the remainder 1, the remainders start to repeat itself. What does it mean? It means that remainders are 3, 9, 11 and 1. See, the remainders are 3, 9, 11 and 1. If you solve it further, you will get the next remainder as 3. You will get the next remainder then 9. You will get the next remainder as 11. You will then get the next remainder as 1. Okay? Now, the remainders have started to repeat itself after 4th power. 1, 2, 3, 4. The next remainder will be equal to what? 3. The next remainder will be equal to what? 9. The next remainder will be equal to what? 11. The next remainder will be equal to what? 1. If you proceed it further. So basically you can say if the power is 4k plus 1. If the power is 4k plus 1, the remainder is 3. See, when the power is 1, see, if you put the value of k as 0, you will get power 1, right? That's why we have written in the form of 4k plus 1. When the power is 4k plus 2, then the remainder is 9. When the power is 4k plus 3, remainder is equal to 11. When the power is 4k plus 4, the remainder is equal to 1. See, 1, 2, 3, 4. This is the remainder when the power is 1. This is the remainder when the power is 2. This is the remainder when the power is 3. This is the remainder when the power is 4. That's why 1, 2, 3, 4. Why we have written it in the form of 4k? The reason is simple, that remainders have started to repeat itself after 4th power. That's why we have written 4k, right? And we have 4k plus 1, 4k plus 2, 4k plus 3, then 4k plus 4. Let us look at this question. See, 3 to the power 4, 5, 6, 7, 8, right? So let us divide 4, 5, 6, 7, 8 by 4. See why we are dividing it by 4? Because we have to write 4, 5, 6, 7, 8 in the form of 4k plus 1, 4k plus 2, 4k plus 3, 4k plus 4. That's why we are dividing it by 4, right? So 4 into 4, obviously 0. Then 5, 4 into 1. Then 6, 4 into 4 is 16. Then you will write 7. So 4 into 1 is 3. Then 8, 4 into 9 is what? 3, 6. So the remainder is 2. Means you can write 4, 5, 7, 6, 7, 8 in the form of 4 into 1, 1, 4, 1, 9 plus 2. Plus 2 means 4, 5, 6, 7, 8 is in the form of 4k plus 2. 4, 5, 6, 7, 8 is in the form of 4k plus 2. What does it mean? If the power is in this form, if the power is in 4k plus 2 form, what does it mean? It means that you will get the remainder that is equal to 9. You will get the remainder that is equal to 9. So the correct answer is 9. So the correct answer is 9. Now let us again solve a new question, right? See, we have solved so many questions. Trust me, if you solve all of these questions and if you look at the solution of all of these questions, you will never have any kind of issue with finding the remainder of powers. So let us solve a new question. The question says, what will be the remainder when 30 to the power 30 is divided by 13? So 30 to the power 3030 divided by 13. You have to answer the remainder, right? You have to answer the remainder. So basically this 30 is divisible by 13. This 30 is divisible by 13, and once you divide this 30 by 13, you get remainder that is equal to 4. So you can simplify it in this way, that this question is equivalent to 4 to the power 3030 by 13, right? Again we will follow the same process. See, we will start solving by when the value is 4 to the power 1, and if you divide it by 13, you will get the remainder that is equal to 4. If you divide 4 to the power 2 by 13, you will get remainder that is equal to 3. See, 4 to the power 2 is what? 4 to the power 2 is 4 into 4, and 4 into 4 divided by 13 is 16 by 13. So remainder will be equal to 3, right? So if you solve it further, 4 to the power 3 by 13. So basically this is again 4 into 4 into 4. Or you can even say that this is equal to 4 into 4 by 13. So 16 by 13. So the remainder is equal to 3. Again, this is equal to what? This is equal to 64 by 30. So you can see that the remainder will be equal to 12. The remainder will be equal to what? 12. If you solve it further, 4 into 4 by 13. 4 into 4 by 4 to the power 4 by 13. See, you can write in this way, that 4 into 4 into 4 into 4, but I will suggest you that we shouldn't write this lengthy calculation kind of things. You can directly write the earlier remainder. The earlier remainder is 12, and you are multiplying with one more 4. See, 4 to the power 3 and 4 to the power 4. So basically you are multiplying with one more 4. So you can directly write 4 into 4 divided by 13. This is equal to 48 by 13. So obviously this value is equal to what? This value is equal to simple, that is 9. 13 into 3 is 39. So you will get remainder that is equal to 9. If you solve it further, 4 to the power 5 by 13, what will you do? Simple again, you can write the earlier remainder and you are multiplying with one more 4. So you can directly write 9 into 4 by 13. 9 into 4 by 13. So this is basically what? This is basically 36 by 13. 36 by 13. Now you can notice one thing. If you solve it further, you will get remainder that is equal to 10. 13 into 2 is 26. And 36, you are dividing 36 by 13. So the remainder is 10. So can you write 4 to the power 6 by 13? Yeah. Again, you can directly multiply the earlier remainder with this one more 4. In 4 to the power 6, there is one more 4. So you can directly write 10 to the power 4 by 13. So 40 to the power 40 divided by 13. If you divide 40 by 13, you will get remainder that is equal to 1. Now tell me, 4, 3, 12, 9, 10 and 1. You can notice one thing, that 4, 3, 12, 9, 10 and 1. These are the remainders. And I have told you earlier that if you once you get the remainder 1, the remainders started to repeat itself. What does it mean? It means that if you solve it further, if you divide 4 to the power 7 by 13, you will get the remainder 4. If you solve it further, you will get the remainder 3. So now you can notice one thing. The remainders have started to repeat itself after 6th power. So basically you can write 6k plus 1. When the power is 6k plus 1, the remainder is 4. When the power is 6k plus 2, the remainder is 3. When the power is 6k plus 6k plus 3, the remainder is 12. When the power is 6k plus 4, the remainder is 9. When the power is 6k plus 5, then the remainder is what? Then the remainder is simply 10. And when the power is 6k plus 6, the remainder is equal to 1. So basically we have to write 3030 in that form, right? So you can write 3030 in that form, in this way, that 6 into 504 plus 6. Or you can directly say that if you divide, you should try to divide 3030 by 6. You should try to divide 3030 by 6. If you divide it, you will get the remainder as 0. You will get the remainder as 0. And if you get the remainder as 0, what does it mean? It means that you will get the remainder 1. Remember this thing. If you write these powers in this way, and if you get the remainder as 0, means you get the remainder as 1. Right? So we have solved so many questions. We have solved so many questions related to the concept of remainder of powers. Right? So I will suggest you that you should solve all of these questions again. And if you are not able to solve, you should look at the solution again. Trust me, after solving all of these questions, you will not have any kind of hassle while dealing with this kind of questions. So hopefully all of you learned something new today. See you in next lecture.